The last form of the line of an equation is called standard form. In Lesson 2.3, now we're looking for the information that a standard form of a line can give you. The standard form itself is a times x plus b times y equals c. Definitely different than what we've seen before, and it's important that we look at what these a, b, and c values might be represented as. For example, an equation might be 2x plus 4y equals 8. Again, we're going to go from this equation to a graph. The first step you might want to do is create a table in which you're going to try to figure out some x and y points that will be on the line. So if we call this column x and this column y, the key is to always plug in a value of 0 for both x and y. Starting with x, if x is 0, and I put it over here, I'll write it above the equation. 2 times 0 plus 4y equals 8. It's as if we can ignore this because 2 times 0 is nothing. That's missing. So it'll be gone now. That means 4 times what number makes 8? If we weren't sure, we can divide by 4 and we realize that y is 2. What that means here is our point is 0, 2. We could plot that on our y-axis. That's called our y-intercept. Now, if we'd like to, we can do the same for the y value. We make it become 0. And our x value, we need to figure it out. So I'll write it below the equation. 2x plus 4 times the y value of 0, because that's what we've chosen to put on our table of values, equals 8. In this case, the 4 times 0 goes away, and we're left with 2x equals 8. Saying 2 times what number makes 8? If we're not sure, we can divide by that 2 since it cancels out multiplication, and x would be 4. That means our point is 4, 0. We call this the x-intercept. And it only takes 2 coordinates to create a line. So from here, I can connect those 2 points and I would be done. Now you may miss the old forms of the equation, and just to remember, for example, a y equals mx plus b, if someone asked what the slope of this line was, because I have it plotted, I could count my rise from the blue dot is 2, or negative 2 down 2, and my run is over 4. So if I put negative 2 over 4 as my slope, remember that can be reduced to negative 1/2. So I know my equation would be y equals negative 1/2 x, and I can even see my y-intercept there of 2, so plus 2. It's nice to see that the graph can always help you find the y-intercept when you're making standard form happen. So let's try another one here. In this case, if I make my x be 0, that would mean 3 times 0 minus 9y equals 18. The 3 times 0 is gone, and I'm able to solve for y by dividing by 9. I'm left with negative 2 for my y value. That tells me 0, negative 2 is my y-intercept for the second line. Then I could switch and make my y value be 0. And if I do that, I'd have 3x minus 9 times 0 equals 18. And the 9 times 0 is gone, so if 3x equals 18, and I divide by 3, I'm given x equals 6. This gives me my x-intercept, and because you only need 2 points to create the equation of a line, there we have it. Just for fun, I see my y-intercept there. That's always found by making your x be 0. So my equation would be y equals rise 2, run 6, so 2 over 6, or I could call that 2 over 6, or 1/3, and my y-intercept is negative 2. It's much easier to get the slope-intercept form when you have graphed your intercepts for standard form. Of course, we could work with point-slope if you wanted to as well. Just squeeze that in down here. You could take either of your points, so y minus my y value of negative 2 would make it plus 2, equals my slope of 2/6 or 1/3 times x minus 0. We can now use our standard form in the intercepts to easily create slope-intercept and point-slope form. Now sometimes you'll have equations that say 4x equals 12, and they want you to graph the equation of a line. If I divide by 4, I get x equals 3. Notice how there's no mention of y. There's not a y involved. This says it doesn't care about y. All it cares is that x equals 3. So this dot has an x value of 3, this dot, all of these dots along this line have an x value of 3. So when I draw this line, it's called a vertical line. As we noted in the first video, in lesson 2-1, this slope that goes up and down is called undefined. So it's not a slope of 0, it's an undefined slope. It's a vertical line. They will always have equations as x equals some number. Whereas if you had an equation with only a y in it and there was no x involved, if you divided by 7, y equals 3. That says it doesn't care, it doesn't care what x is, it just cares that the y value is always 3. This is a horizontal line, and this slope has 0 slope. It will always be an equation that says y equals a number. Now that we've talked about all 3 types of lines, you should be able to take an equation and make a graph, or take a graph and make an equation, or even some other type of information, say a slope and a point or 2 points. With lots of types of information, you should be able to make each of these equation types, and quite possibly go between the 2 types of formulas. There's lots of ways to convert them, and make sure you practice them all.